Hello everyone, this is Heading Tian. We are learning chapter 7.3, the law of cosines today. When solving oblique triangles SSS and SAS, we need to use the law of cosines. What is the SS case? So if the given information is 3 sides, know the length of 3 sides, and then we can use the law of cosine to find the other 3 angles. What is the SAS case? So we know 2 sides and we know an angle. Then this case is SAS. So the A is between 2 sides. Let's see, law of cosine. For the triangle ABC, it has 3 sides. They are lowercase ABC represent the lengths. The opposite of the 3 sides, they are uppercase ABC. Then the relationship between the lengths and the angles, we are using the law of cosines. We have A squared equals B squared plus C squared minus 2BC times cosine A. And then if I want to isolate the cosine A from the equation here, we can first isolate the 2BC times cosine A. So if I have the given equation, we can add 2BC cosine A both sides. Then, so let's do this here. We have 2BC times cosine A plus A squared equals B squared plus C squared. And then continue to get rid of the A squared. So 2BC times cosine A equals B squared plus C squared minus A squared. Get rid of the BC, 2BC. Do the division. So cosine A equals B squared plus C squared minus A squared over 2BC. So if you do not remember the alternative form, you can only memorize the laws of the sign in the basic form and then convert it to the alternative form to find the cosine A. And if I want to find the angle A, we can use the inverse function of the cosine. So cosine B squared plus C squared minus A squared all divided by 2BC. We are not only having only one formula, we also have the B squared and C squared formula. If I have a B squared equals A squared plus C squared minus 2AC times cosine B. So I can also isolate the cosine B. C squared equals A squared plus B squared minus 2AB times cosine C. Cosine C equals A squared plus B squared minus C squared, all divided by 2AB. All right, please spend some time, pause the video, and write them on your notes, on your notebook, and or on your scratch paper several times until you can memorize them. Okay, let's use law of cosine to solve the SAS case. Use the law of cosine to find the opposite side, because if we have the SAS case, so we want to find this side first. So that's the opposite of the angle A by using the law of cosine, because I assume that this angle, so I say this is ABC. And then know the lowercase b, I know the lowercase c. I also know the angle A. Can you find the lowercase a? So the A is not given. A squared equals B squared plus C squared minus 2BC times cosine A. So BC and A, they are all given. I can find the length of A and then square root both sides, find the A. Second step, use the law of sine, find the angle opposite to the shorter side. So let's see which is shorter. So B is shorter or C is shorter. It all depends on the question. So for example, I have a shorter C. C equals 15 and B equals 14. So, So for example, B equals 20. So C is shorter. And then I can say I use A over sine A. I found my A from my first step, step 1. And then A over sine A, angle A is given. And the C is shorter, so I'm using the C over sine C. So C, A, uppercase A, they are all given. I can find angle C by using the law of sine. Why I'm using the law of sine to find the shorter side? Because if I have a triangle, the shorter side is the opposite of the small angles. If I have a longer side, the opposite of the longer side is the angle is greater than the small angle. Because as the angle increasing, the sine's value is increasing. And also the opposite of the angle A is also increasing. So if I can find the shorter side, so this side, the opposite angle must be an acute angle, less than 90 degrees. Oh, that means I don't need to find the inverse of sine in both quadrants because the acute angle must be in the first quadrant. So I don't need to worry about the angle in another quadrant. So easier. So remember, if you don't understand why, so remember that if the law of sine to find the shorter side, and later we will learn use the law of cosine to find the longer side. So cosine, law of cosine find the longer side. Law of sine find shorter side. Okay, let's see the first example. Example 1, solve the following triangle, round to the nearest tenth. I do not have a graph. Maybe let's graph it. So if I have maybe like this, A, B, C. So the angle A is given is 52 degrees, and angle B is not given. Side B is 22. And side C equals 35. We need to find, first we need to find the A. So we know the formula is A squared equals B squared plus C squared minus 2BC times cosine A. Then the A equals square root of B squared, 22 squared, plus C squared, 35 squared, minus 2BC, 2 times 22 times 35 times cosine 52 degree. Then we use our calculator to find the value. Okay, so square root of B squared, 22 squared, plus 35 squared, minus 2 times 22 times 35 times sine, why I'm clicking sine, multiply by cosine 52. Close the parentheses and hit enter. If the question says round to the nearest tenth. Nearest tenth is digit after the decimal point. That's a 5. So after 5 we have an 8. So we are having 27.6. 27.6. This is centimeter because the B and C, they are all centimeter. And what is the next? So which angle I'm looking for? I'm looking for the shorter side. Now we have 2 given sides. They are B and C. Which one is shorter? B is shorter. So I can list the relationship between the B and A. So B over sine B equals A over sine A. Why I'm listing the relationship law of sine between the B and A? Because let's list the let's use this color write the given information. So A, I found the A from here, and I know the angle A is 52. And what else? I know the side B. And how about the angle B? Unknown. So only one unknown information. Let's solve it. So I try to flip the upside down. So sine B over B over equals sine A over A. So multiply by B both sides. I isolate the sine B equals B times sine A over A. And then the angle B equals the inverse of the sine B over sine A over A. Then we use our calculator to find angle B. So angle B is inverse of sine. What is B? 22. Multiplied by sine A. Sine A is 52 degrees. All divided by A. A is 27.6. So let's use calculator to do the computation. We have inverse. Second, sine is inverse of sine function. 22 times sine 52, close parentheses, all divided by 27.6. Close parentheses, let's see. Okay, that's 38.9 because we rounded to the nearest tenth. So it's 38.9 degree. So if, for example, if you say, why I input the same data, but I do not have the same solution like yours, so maybe you are having a radian mode. So click mode, you check your mode is in radian or degree. So this one is degree because I'm inputting the data sine 52. 52 is degree mode. So make sure you have your degree mode. So do I have everything? No, I have the angle A, angle B. Do you have angle C? No. So angle C equals 180 minus A minus B degrees minus A minus B. So the C is 180 minus 52 degrees minus 38.9 degrees. So if we use our calculator, we're going to have 89.1 degree. Now I have everything. I can list every information here. Angle A equals 52 degree. Angle B equals 38.9 degree. Angle C equals 89.1 degree. And A equals 27.6 centimeter. And B equals 22 centimeter. And the length C, the side C, the length is 35 centimeter. So we found everything. We solved the triangle. Let's see next case. Next example. Read the question, solve the triangle, round to the nearest tenth. It gave us angle B, A, and C. Let's graph it. So I need to have my graph. Maybe draw a very similar triangle. So ABC. Where is the B? B is here, 42.3 degree. And the other information is A equals 12.9. C equals 15.4. This is also the SAS case. SAS case, I need to find the B first. So some of you will ask, why you do not use the law of sine to find this? I know that the law of sine is A over sine A equals B over sine B and C over sine C. So let's use the red color to highlight the given information. So A is given, and angle B is given, and C is given. So if I ignore this, so in one equation, I have two variables, A and B. I cannot solve it. And if I look at another equation here, so in this equation, I have two variables, and I have only one equation. I cannot solve the ABC. That's the reason I cannot, in this case, I cannot use the sign of law of sines. So first step, by using the law of cosines to find the SAS case, is finding the B. That's the opposite of the given angle. So B equals A squared plus C squared minus 2AC times cosine B. So let's use the calculator to evaluate this information. A squared is 12.9 squared plus C squared. C squared is 15.4 squared. Minus 2AC, 2 times 12.9 multiplied by 15.4 and multiplied by cosine B, and B is given. B is 42.3, so cosine 42.3. Then we use our calculator to evaluate the value. So second, x squared, that's square root. Then we have 12.9 squared plus 15.4, all of the squared, minus 2 times 12.9 multiplied by 15.4, and then multiply by cosine 42.3 degrees. Then hit enter. So we are having 10.4737 something. So round to the nearest tenth, we have 10.5. It's 10.5, and the unit is also centimeter. And what is the next? I'm using law of sine to find the opposite of the shorter side, the angle. So the A and C, which is shorter? A is shorter, so I'm listing the law of sine. A over sine A equals B over sine B. So we found the B here, lowercase b here, and also the B, uppercase B, the angle is given. Now I'm looking for the sine A. Sine A is at the bottom. Let's flip it upside down. I'm having sine A equals, over A equals sine B over B. So isolate the sine A. Sine A equals A times sine B over B. So sine A equals A, what is A? 12.9. Sine B is sine 42.3 degree. All divided by B. B is 10.5. Then the angle A is the inverse of sine. All of this. So that's 12.9 times sine 42.3 degrees, all divided by 10.5. So let's use our calculator to find this. We're looking for second sine. That's the inverse of sine. That's 12.9 multiplied by sine 42.3, close the parentheses, and then all divided by what? All divided by 10.5, close the parentheses. Okay, hit enter. So we have 55.775. Round to the nearest tenth, I have 55.8. So the angle A is 55.8 0.8 degree. What is the next step? So I have two angles. I'm looking for the angle C. Angle C equals 180 minus A minus B. So 180 degrees minus 55.8 minus B, 42.3 degree. We can use our calculator. 180 minus 55.8 minus 42.3. We have 81.8. So the C is about 81.8 degrees. So I can do some conclusion. You can say A equals 55.8 degrees. Angle B equals 42.3 degrees. Angle C is 81.9 degrees. And A equals 12.9 centimeter. B equals 10.5 centimeter. And C equals 15.4. Okay. So we are done for the SAS case. How about SS case? Now I know the three sides. And what is the first step to find the missing information? Find the largest angle using the law of cosine. We find the largest first because it is the only angle that could possibly be obtuse. Yes, because the opposite of the longest side, that's maybe obtuse, maybe that's acute. So this has a possibility to be obtuse. Since we are using the law of cosine, there will be no ambiguity about the measure of this angle. So we must find the opposite of the longer side. Second, find either remaining angle using the law of sine. Number 3, find the remaining angle using the angle sum formula for angle A plus B, for a triangle A plus B plus C equals 180 degree. Let's see from the example 3. Solve the following triangle round to the nearest tenth. So maybe I can graph it, for example, don't move. So for example, randomly draw a triangle and let's say ABC. A is given 9.3 and B is given 5.7. C is given 8.2. And then the first step says, if this is SS case, so use the law of cosine to find the longest side. So longest side, which is the longest side? A, because A is 9.3. And the cosine A. So use the alternative native formula. Cosine A equals B squared plus C squared minus A squared, all divided by 2BC. So if you do not remember that, so you know, first step I need to find angle C, you can use the original formula, which is A squared equals B squared plus C squared minus 2BC times cosine A. Isolate the A, then you have the same formula like this. Then let's input all the data. So we have 5.7 squared plus C squared, 8.2 squared, minus A squared, minus 9.3 squared, all divided by 2 times 5.7 times 8.2. This is cosine, and then later we are looking for the inverse of cosine. So if I want to find the inverse of cosine, so angle A is inverse of cosine. Inverse of cosine, so put everything in the parentheses, which is 5.7 squared plus 8.2 squared minus 9.3 squared, all divided by 2 times 5.7 times 8.2. So let's see the calculator. We are looking for inverse of cosine. Click second cosine and then put the data in it. On the top of the, so inside we are having a top, half the bottom is a fraction. So on the top we are having, so use the parentheses to box the top. We have 5.7 squared and then plus what? Plus 8.2 squared. And then minus 9.3 squared. All, so close the parentheses. These all are the information on the top. Divided it by the bottom. Bottom is what? Is 2 times 5.7 multiplied by 8.2. Close the parentheses. So the top has the parentheses, bottom has the parentheses. Hit enter. Close the parentheses, hit enter. So we are having 81.857 something. So round to the nearest tenth. I'm having 81.9. So the angle A is 81.9 degree. And what is the next? So we know the angle A. We only know one angle, so we can find the other angles by using the law of sine. So it doesn't matter right now, you choose the B or C, angle B or angle C, because the A is the longest side. So this A must be the greatest angle, or it has the greatest measure of the angle. So if the A is obtuse, this is obtuse. If this is a acute angle, this is a, so other angle also acute. And if it's obtuse, still B and C, they are acute. So it doesn't matter you choose which one, B or C. So if I'm choosing the B, I have a lot of space here. So if I'm choosing the B, I'm using the B. So I'm using the A over sine A equals B over sine B. What is the given information and missing information? So angle B is missing. A, lowercase a, uppercase a, lowercase b, they are all given. So let's find sine B. I'm trying to flip this. So I'm having sine A over A equals sine B over B. Isolate the sine B. Multiply by B both sides. So sine B equals B times sine A all divided by A. So my B equals the inverse of sine B times sine A over A. And the B equals the inverse of, what is the B? B is 5.7. And sine A is sine 81.9 degree. All divided by A. A is 9.3. So let's use our calculator to find the value. Second, sine, that means the inverse. And then we have 24.6. No, sorry. So we have 5.7. So we have 5.7 multiplied by sine 81.9. 9. All divided by 9.3. Close the parentheses. So I'm having 37.357 something. So round to the nearest tenth, I have 37.4. So B is about 37.4 degree. So you have angle A, angle B. Can you find angle C? I don't need to use a law of sines again because I know the two angles of the triangle. So use addition equals 180. So you to find the angle C, 180 degree minus A minus B. So 180 degrees minus 81.9 degree minus 37.4 degrees. So what is the angle C? So we have 180 minus angle A is 81.9 and angle B is 37.4. And then hit enter. Is 60.7 degree. Now I have three angles and I have the three sides because three sides they are given. I can list it here. A equals 81.9 degrees, B equals 37.4 degrees, and C equals 60.7 degrees, and A is 9.3 centimeter, B equals 5.7 centimeter, C is 8.2 centimeter. Okay, let's see next example. So let's do a little conclusion. If I have SSS case, what should I do first? So I will find the angle of the longest side first using the law of cosine. Second, find the other missing angles by using the law of sines. And then use the addition of the three angles equals 180 to find another missing angle. All right, let's see the numbers 4. Solve the following triangle round to the nearest tenth. So here we have the information ABC. So we can randomly draw the image. Maybe this is not the right image. I don't know. Because when I see the length, I feel C is very long. Maybe I will draw a long C. So let's see. Say this is C, A, B, C. And C is opposite is 33.5. centimeter, and A equals 24.6, B equals 16.2. Let's find what is the angle C because it's the opposite of the longest side. So I know that cosine C. The formula is A squared plus B squared minus 2AB times, minus C squared, all divided by 2AB. All right, so we can input all the information in it. So A squared is 24.6 squared plus 16.2 squared minus C is minus 33.5 squared, all divided by 2 times 24.6 times 16.2. And then we are looking for the angle C. We are not only looking for the cosine C. So angle C is inverse of cosine. All of this. I don't want to copy. So let's use the calculator to do this. So second, cosine. And on the top, we have very complex expression. We have addition, subtraction. Let's use parentheses to box the top. 24.6 squared plus 16.2 squared, and then minus, 16, not 19. 16.2 squared, and then minus 33.5 squared. Close the parentheses. This is the top. All divided by the bottom. Bottom also has complex expression. 2 times 24.6. And then multiply by 16.2. 16.2, close the parentheses. Okay. And then close the parentheses. Hit enter. Okay, I got the angle C. Do not forget you have the inverse of cosine. So the C is about 108.6 degree. Okay, if I found the C, I can find the A or B. I can pick any of them. So if I'm looking for, how about the A? I know that using the law of sines is A over sine A equals C over sine C. So A is 24.6. Sine A is not given. C is 33.5. All divided by sine 108.6 degree. So I'm solving for the angle A. Let's flip this. I'm having sine A over 24.6 equals sine 108.6 degrees, all divided by 33.5. Then I multiply by 24.6 both sides. Sine A equals 24.6, which is A. 24.6 multiplied by sine 108.6, all divided by 33.5 degree. Oh, sorry, no degree. That's the length. How about the A? So the A is inverse of sine. All of these. That's a little bit long. That's 24.6 times sine 108.6 degrees, all divided by 33.5. And then let's use our calculator to do the computation. So we are clicking inverse of sine. So inverse of sine 24.6 times sine 108.6. Oh, okay. Close the parentheses, all divided by 33.5. Close the parentheses, hit enter. That's the angle of A, 44.1. So the A is about 44.1 degree. So we got two angles. We can find the angle C is 180 degrees minus A minus B. So it's 180 degrees minus 44.1 degrees. Sorry, the C has been found. We are looking for the B. Then minus C. C is 108.6 degrees. So the angle B is do the subtraction. We have 180 minus A. A is 44.1 minus B minus C is 108.6. So we are having 27.3 degrees. So we got three angles. They are ABC. A equals 44.1 degree, B equals 27.3 degree, C equals 108.6 degree, A equals 24.6, B equals 16.2, C equals 33.5. These are all the centimeter. All right, we're done here. Here is the summation or summaries. The summaries of steps needed when solving the oblique triangles. So let's do the conclusion. So if you have SAA or ASA, you will see we got two A's or two angles. Or the case here. Well, if we have the two angles, first step, I'm using the addition of three angles equals 180. Find the missing angle. Second step, use the law of sines to find the remaining sides. And if I have the SSA, this is a special case because this one we call the ambiguous case. I have two sides, S and S, and then I know one angle, this angle. I know only these three information. Maybe this is acute angle like this. Or maybe it has no angle exist because this S is so short. So it will not construct a triangle. Even I move it here, but still it will have no intercept with the line here. So maybe I have no triangles, or maybe I have two triangles. For example, if I have okay, so if I have this S and so SSA. So given these three information, maybe I can construct the acute triangle, or maybe my S is here. So this side, they are the same length. So I can also construct a triangle like this. So maybe it's a triangle like this, or maybe I have the triangle like this. It all depends on what is the value of SA. Okay, so let's see the SSA case. So step 1, find either unknown angle using the law of sine. If no such angle exists, then there's no such triangle exists. That's the case here. So when we have no triangle, when we are solving the equation, for example, I have sine A is greater than 1. So it's impossible because the sine A cannot be greater than 1. The sine A is between -1 and +1. Step 2, find the quadrant 1 angle exists. Also find quadrant 2 angle. That means when I'm solving my equation, I got sine A equals, for example, 1/2. So the sine A is positive in the first quadrant or second quadrant. So we are not only having one solution for the A. If in the first quadrant, by using calculator, I know the inverse of sine 1/2 is 30 degrees. So I know that this is the first solution. Also, I could have another angle here in the second quadrant, reference angle, also 30. So the A could be 30. A also could be 150 in the second quadrant. Number 3, find the remaining angle for both of the possible triangles. So these two, they are possible triangles. They are not the, for sure, we have two triangles. So I need to test if this A plus the given angle, because I have the given angle here. Maybe I say this is a B, is greater than 180. So there is no such A exist. So we only have one angle, A equals 30 degree. So number 4, find the remaining side of each valid triangle by using the law of sine. So next, we have learned the SAS and SSS case. In this video, we are using law of cosine. First, use the law of cosine here in the SAS case to find the opposite of the A, and then use the law of sine to find the missing information. Okay, and we are using the law of sine to find the smaller of the two remaining angles. Okay, then we use the sum of the three angle equals 180 degree to find another missing angle. Next one, SSS. So first step, find the largest angle by using law of cosine. And then number 2, find the either remaining angle using the law of sine. Number 3, find the remaining angle using the angle sum formula for the triangle A plus B plus C equals 180 degree. All right, we are done for today. If you have any question, please let me know. See you next video. Bye-bye.